All right, we are going to talk today about piecewise functions. This is the last bit of material that we need to go over. On Monday, we'll go over a quiz review, kind of practice some problems. Tuesday will be your quiz. If some of you are feeling a little overwhelmed, like this is a lot, I understand. Like we hit the ground running with this. But let's get through the first quiz and then reevaluate. All right, just come to me. You need to stay on top of things. Get extra help, extra practice, those sorts of things. Make sure you're communicating if you need something. But how many of you have talked about piecewise before? Seen it? Talked about it? Okay. All right. You may not remember it, that sort of thing. We're going to do two different things. We're going to talk about how to evaluate a piecewise function and then actually how to graph one. So this is what a piecewise function looks like. What is f of x a fancy way of saying? Y. Okay. So this is y equals, right? Y equals, and then you have two different equations. 2x plus 3 and negative x plus 4. What shape do both of those make? If I was going to graph it. Y equals 2x plus 3. What kind of form is that in? Slope intercept. So what is this going to make? Slope intercept is the equation of 8 line. Good. X to the first power, guys, makes a line. What does x squared make? A parabola, good. What does x cubed make? Anybody remember? Snaky looking thing. All right. So it's a good idea to have an idea of what your graph should look like by just the equation given. What is a piecewise function? Okay. If I said to you to evaluate f of negative 3 and f of 2. Does anybody know how I would do that given the information that's there? Tell me.
You plug in negative 3 as x, and that's what you get your y.
Okay. Where am I going to plug in negative 3? To which equation? The top one or the bottom one?
The top, because it has to be below.
Correct.
Equal or below 1.
Correct. A piecewise function, when you're evaluating and you're graphing, you are given these constraints or boundaries or however you want to look at it. But when you are told to evaluate, they're saying, hey, here is the value of x that I want you to plug into one of the equations that's here. How do you know which equation to use? Well, look at the number they want us to plug in first, negative 3. Is negative 3 less than or equal to 1, or is it greater than 1? Less than or equal to. So then I'm going to evaluate using the top equation because that's where this value fits in. So you would say 2 times negative 3, negative 6 plus 3 gives me what? Negative 3. Okay, that's how you would evaluate. So which equation would I use if I'm going to find f of 2? The bottom one, because 2 is greater than 1. So you would say negative 2 plus 4. I come out with the whole number 2. Yeah? Okay. So all piecewise functions is pieces of graphs that they're talking about. And the pieces that you figure out are determined upon the boundaries that are given to you. When we graph, right? Say I was going to graph these two lines. And I have, at the end, I have a dot. If it's open or closed. In the top equation, is my dot closed or open? Closed. How come? Because the or equal to underneath. Good. And the bottom one, it's what? Open, because it's not or equal to. Okay, good. So many of you have probably seen piecewise before. If you've taken the SAT or ACT, I'm sure there's been something on there. Piecewise graphing is not incredibly difficult if you do it a piece at a time. If you try to do everything all at one time, you're going to get yourself confused. So I'm going to show you what I think is the easiest way to do it, and then you guys can go from there. So we're going to do 3 examples. I'm going to do 55, 59, then 57. So let's look at 55 first. First of all, f of x is a fancy way of saying y, okay? So I'm going to write down the two equations. I have y equals 2x plus 3. And I'm going to change colors and say y equals negative x plus 3. Am I allowed to change the order like that? Yeah, I don't like when x is second. I don't know why. So look at x is to what power? First power. So we're going to make a line here, okay? So in blue, and I have color pencils you guys can use on the quiz, but in blue, what is the slope and what is the y-intercept? Okay, your slope is 2 over 1. Perfect. And what's the y-intercept? 3. Is this a positive line or a negative line? It's positive. So what direction does it go? Up, okay? I like to just give myself a little mental picture just so I don't forget. And then over here in red, what's my slope? Negative 1 over 1, good. And what's the y-intercept? Perfect. And it's a negative line, right? So it's going to go like that. Now, all we're going to do is graph two lines. That's it. And you're going to determine which piece of the line we want, which piece we don't want. That's it. That's all piecewise is. So let's graph the first one in blue. It's easier for you guys to do on Notability. You'll see why when I do this on Explain Everything, why it's a little more difficult, just erasing-wise. But so I'm going to put a dot at 3. Do you guys agree? And then from that point, go up 2 over 1, up 2 over 1. So I'm going to come here. And I'm going to put a dot right here at 3. I'm going to go up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. I'm going to connect my dots with a dotted line just because I'm going to erase part of it. You can do a solid one if you want. It's just easier to erase when I do this. Now, this is the part of piecewise. I look at the boundaries that they gave me. I want the top part where all the values are greater than 0, and the bottom part where they're, less than 0, and the bottom part where they're greater than or equal to, correct? You guys see that? Do you see how the first equation says 2x plus 3 where x is less than 0? Yeah. So this is going to be an open dot. This one's going to be closed. And what I mean by that, what is the number on the x-axis that I'm looking at? X is less than 0, x is greater than or equal to 0. So where am I looking on the x-axis? What number am I using as my dividing line? 0, okay? So I'm going to come over here to 0. I'm going to draw a line right here. So the first equation, the part of the line that I want, is all of the values that are less than or equal to 0 on the x-axis. So when I look at that yellow line I drew, where are the values on the blue line? Where are they less than or equal to 0 on the x-axis? Is it the left-hand side or is it the right-hand side? It's the left. So this is the stuff I want to keep. And what do I do with the other stuff? I get rid of it. I'm going to erase it. I only want that piece of the line. And then what kind of a dot do I have right there at 0? Why is it open, Jacoy? You're right. Because there's not a line underneath. So all you're doing is you're going to graph whatever is given to you. And then you look at that boundary line. Whatever number is there, you draw a vertical line. If you want the stuff that's on the x-axis that's bigger, you want the stuff on the right. If you want the stuff that's smaller, you want the stuff to the left. So my second line, where am I putting a dot? For red, where am I putting a dot? At positive 3, okay. And then what's my slope? Negative 1 over 1. So I'm going to go down 1 and over 1, down 1, over 1, up 1 over 1, up 1 over 1. And I'm going to draw my line. This is what my line would look like. And now I'm going to look at my boundary. What is my boundary line here? Where do I draw a vertical line at? At 0, okay. Sometimes it's the same as the other equation. Sometimes it's not. And then I want all the values on this line that are greater than or equal to 0. So do I want all the stuff on the right side or all the stuff on the left side? The right side. I want this stuff over here. And then what do I do with the other stuff? I'm going to erase it. Good. And then what kind of a dot is there? Closed. So yes, at this point, one part of it is open, one part of it is closed. The closed will always supersede the open. So there's your piecewise graph. It's a piece of the blue line and a piece of the red line.
On a test or quiz, how will you see the open circle?
If it's on the exact same spot, it should be closed. Yeah. And if you have a piece, just say you had like a piece up here and it went like this. And you guys wanted me to make sure you knew it was open. Just go, you can go like this and write the word open. Just so I know, okay, hey, that's supposed to be an open dot, you know, whatever. But again, you guys can borrow my color pencils. You're welcome to use them on your quiz. Let's go down to 59. All right, how's 59 a little bit different? There's 3, okay? No big deal. Everything's to the first power. So I'm going to say y equals x plus 3. I'm going to say y equals 3. And I have y equals 2x minus 1. Okay, we're going to do the same exact thing. Now we have 3 things to graph. So in this first one, blue, what's my slope? What's my y-intercept? Slope is 1 over 1. What's the y? And this is a positive line, so it's going to go like that. Let's talk about the black one. What's my slope? 2 over 1. What's the y? Negative 1, so it's a positive line again. It's going to go this way. What is the green line? It's what? No, it's a line. Why is it a horizontal line? You are correct, my dear. Because it's a y equals. There's no slope. Your slope is 0. Whoops. Slope equals 0, and your y-intercept is at 3. Now, some of you are like, how did you know that? If you need to, draw a little picture. Where is y equals 3? 1, 2, 3. The line goes through it, so you see it's a horizontal line. If we don't memorize y equals is a horizontal line, that's okay. You can still draw it and figure it out. So now, guys, how many lines are we going to draw on our piecewise? 3. So the first one I'm doing blue. I'm gonna do it here on 57. And then I'll switch the other one just because it's right there. So where is my intercept? At 3, okay. Positive slope, so 1 over 1. Everybody agree? All right, we graphed a line, no biggie. So where do I look and what kind of dot do I have? Where am I drawing my vertical line? That's my dividing line. At 0, okay? So what kind of a dot do I have at 0? It's closed. Why is it closed? Because it's greater than or equal to. Good. So I want all the values on the x-axis that are less than or equal to 0. In regards to that red line, where are the values on the x-axis less than or equal to 0? To the left or the right? To the left. So I want all this stuff, and what do I do with the other? I erase it. Good. Perfect. All right, let's look at the next one. Y equals 3. That's an easy one. Where is y equals 3? It's a horizontal line at 3. Okay, good deal. Now, where am I drawing my vertical line? Or lines? At 0 and 2. Good. So I'm going to draw one here at 0 and one here at 2. So what do I want to keep? The stuff in between those vertical lines or on the outside? What does the inequality say? All the values where? Between 0 and 2. Perfect. So I'm going to keep this stuff and do what? Erase the other. Now check your dots. You already have a closed dot where that first one is, so it's fine. What should the other dot be on the other end? On 2, what should it be? Closed. So here we go. Close it up. There's the second piece that you guys wanted. And now we're going to do the last one in black. Where is my intercept? -1, okay. What's the slope? So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Now, a lot of times these graphs connect. Sometimes they don't, so don't freak out if it doesn't. But in this one, where do I draw my division, my line, my vertical line? At 2, right? So I'm going to draw it here at 2. On the x-axis, guys, where are all the values greater than 2? To the right. And that line is already closed, so you don't have to worry about should it be open or closed. Because if it's already closed, you just leave it closed. And then what do I do with all this other stuff? I erase it. So there's my piecewise function. It's 3 pieces of 3 different graphs. If you try to do all of this at one time, where you're just graphing the line in your head and you're trying to figure, you're going to get yourself confused. Take the time to say, okay, here is the whole line. What do I want to keep? What do I want to erase? Second part, what is the whole line? What do I keep? What do I erase? Does that make sense? All right, do the last one. 57. Now, think about 57. If you guys have something like this in a test or a quiz, Miss Thompson and I will give you values to use just so it's a little easier. If you don't, say you have an x squared or an x cubed, and you don't know what the shape's going to look like, you can't graph it just from the equation, use a table of values. Pick some negative numbers, pick some positive numbers, plug in for x, and see what you get out for y. But this one I'll help you out a little bit because it's a little harder because it's a square root. So I have two. I have y equals the square root of 4 plus x. And then I have y equals the square root of 4 minus x, right? Yes? Okay, so I'm going to give you some values to use, to think about. So x and y. Let's use -8, -4, 0, and 5. And over here, we're going to use we'll go backwards. 5, 0, -5. That's fine. Okay, so we're just going to evaluate because I don't know exactly where these points are, so let's evaluate in red. So if I plug in -8, guys, what is 4 plus -8? -4. What's the square root of -4? It's imaginary, right? Good, Jokoy. Can I put that on a graph? No. Okay, so nothing exists there. So let's plug in -4. So what's 4? Square root of 4 plus -4? Square root of 0. What's the square root of 0? 0. Good. So now I'm going to plug in 0. So I have 4 plus 0. What's the square root of 4? 2. Good. Now I'm going to plug in 5. 4 plus 5, square root of 9, which is, okay. So let's plot those points. -8 doesn't have a point that exists. It's imaginary. So I go to -4, 0. 0, 2, and then 5, 3. Right, and this shape is actually kind of like a wave kind of thing, the square root graph. Oh, I should have done it. Sorry. I just gave you points to use. If you guys picked your own, since it's a square root, I knew what was going to work and not work. Just easier. If it's a square root graph on the test or quiz, we'll give you points to plug in. All right, so now I'm going to look back at my equation. What are my boundary lines? Where do I draw my vertical line? At 0. Okay, so this first one that we just graphed, I want all the stuff on the x-axis that is less than 0. If I look at that green line, where are the values on the x-axis less than 0? To the left. So this is what I want. And what do I do to the rest? I erase. Good job. What kind of a dot's there? Look at the inequality. What is it? It's open. Why is it open? Because it's just or. It's not or equal to. Good. Okay, so now I'm going to evaluate using the other ones I just put in. So I say, okay, square root of 4 minus 5 is what? Square root of -1. Does that work? No, okay. So I say, okay, so back here, we're plugging in 0, right? So it's 4 minus 0. So square root of 4 is what? 2, okay. And then when I plug in -5, 4 minus -5 gives me square root of 9, which is 3. So then I have 5, 0 is nothing. Then I have 0, 2. And then I have -5, 3. 1, 2, 3. When I did the last example, I used -4 and -5, so I thought, well, I just won't do it. And then now I realize my mistake. Thank you. Thank you, thank you, thank you. All right, so what should I plug in? Tell me. Oscar, tell me. See, I tried to be creative and do different numbers. All right, so let's do this. Let's do X, Y again. All right, so I'm going to use... What'd you use, Oscar?
I use the same numbers you use. I just put a 4 as an extra.
Instead of a 5, right?
Yeah.
Okay, so let's do 5, 4, 0, and negative 5, right? Okay. Oh, Lord, thank goodness it's Friday. So 4 minus 5, square root negative 1, right? Yes? Can't have, all right? So let's do 4 minus 4. What's the square root of 4 minus 4? Perfect. Now we're going to do 4 minus 0. Square root of 4 is? Now we're going to do negative 5. 4 minus negative 5. 4 minus negative 5. Square root 9, which is 3. Yeah? Okay, so let's plot these. So 5, 0 doesn't work. 4, 0 is right there, correct? 0, 2 is right there. And then negative 5, 3 is right there. My point wasn't showing up because I decided not to use that number. Now this makes sense. Okay, where's my division line? What number? 0. Look, where does it say that we're looking at? Now I want all the stuff that's greater than or equal to. So I'm going to have a solid dot. And where on this graph are the values greater than or equal to 0? To the right. And then what do I do with everything else? I erase it. So this is what my graph looks like. Are your graphs going to be perfect? No. But again, if you do have a square root graph, we will give you a table of values so you don't get yourself stuck on something.
When you're doing this, can you use like any value?
You can use any value you want to. It'll work fine with a line or a parabola, but in a case of a square root, you know, say I plugged in here, if I was like, okay, I'm going to use 6. So I have the square root of 4 plus x. Well, when I plug in 6, I'd get the square root of what? 10. Where's the square root of 10? It's a little bigger than the square root of 9, right? So it's a little bigger than 3, but it's less than 4. So those are hard points for you guys to graph. So if there is a radical, if there's a square root graph in there, we'll give you numbers to plug in so they're whole numbers that are easier to deal with. Other than that, just use an XY table and plug in couple negatives, couple positives, and a 0. Sound good?